So next, let's find the dimension of kinetic energy. Now, do you know that work is the same as energy? What is energy? We define energy as the ability to do work. And then we define work as the measure of energy transfer. So energy is the ability to do work. Work is when you are using energy to perform a task. So the first thing we need to do is to find the formula of kinetic energy. So the formula of kinetic energy is half mass times velocity squared, or we normally write it, we are mostly familiar with it this way: half kinetic energy is equal to half mv squared. It's the same thing that I've expanded here. Now the next step is to find the dimension of both sides. So dimension of kinetic energy equals the dimension of half times dimension of mass times dimension of velocity squared. So remember we said that we don't take dimension of numbers, so dimension of numbers do not exist. So now we have two quantities here. We have mass, we have velocity. So what we need to do is to know the dimension of mass and dimension of velocity, and we have them here. Dimension of mass is m, dimension of velocity is lt or minus 2. You substitute them here and then you have the formula or the dimension of kinetic energy. Remember, we said we don't take dimension of numbers. So kinetic energy is mass times LT exponent minus 2 all raised to the power 2. So in indices, as a law of indices, we know that if you have AB all raised to the power x, if you're expanding this bracket, you are getting A exponent x, B exponent x. So it means that this L will be raised to the power 2 and T power minus 2 will be raised to the power 2, which will make it ml squared T exponent minus 2. So this is the dimension of kinetic energy. Now, do you remember what we had for work? Is it the same as what we are having here? So compare and see if they are the same. And if you notice that they are the same, it means that what we are seeing here, that work and energy are similar or the same or carry the same properties or characteristics, is true. So since we had the units of work from ml squared T exponent minus 2 to be kilogram meter squared per second squared, that of energy or that of kinetic energy is also going to be kilogram meter squared per second squared. See, take note of this. So as I said, try different formulas for different energies. For instance, kinetic energy or heat energy or any energy, you know the formula. Try to find the dimension by breaking it down to the basic quantities and see if you get anything different from what you've had here. So my last example for the day is the dimension of moment. So let's find the dimension of moment. We begin by writing the formula for moment, which is the force multiplied by the perpendicular distance. Moment of a force is the measure of its turning effect about a pivot. So let me assume this to be a pivot or a knife edge, and I have a horizontal bar on it with a load being mounted here. Because the weight is acting downwards, I'm going to get this bar turning in this direction about this point. So we get this bar turning in this direction about this point. So this effect is what we refer to as the moment of the force that is being exerted by this load. And this moment is the product of the distance between the point of application of the force and the force itself. Now you know that weight is the same as force. So back to what we are doing for the day, moment is equal to the force multiplied by the perpendicular distance. Now remember we said perpendicular. The force acts in this direction, one direction, and then the distance is always perpendicular or at right angle to the point of application or the direction in which the force is being applied. So that is what we mean here. So moment is equal to force times perpendicular distance. That is our first step. The next step is to find the dimension of both sides as we've discussed in our previous videos. Now after finding dimension of the both sides, now after finding the dimension of both sides, what we need to do is to find the dimension of each individual component. Now we know the dimension of force to be mLT per minus 2 and dimension of distance to be L. All we need to do now is to substitute these two elements or these two components into this formula to get the dimension of moment. So the dimension of moment is equal to mLT per minus 2 multiplied by L. So this is the dimension of moment. Students sometimes confuse moment with momentum, but unfortunately moment is not equal to momentum. They are not the same. Momentum. So I want you to find the dimension of momentum so that we compare with the dimension of moment. So try this and let me see what you had in the comment section. So this is where we end our lesson for the day. Don't forget to subscribe, like and share with your colleagues so that they can also benefit from this free lessons.